Herkese merhaba, hoş geldiniz. Bugün yine çok keyifli bir webinarla karşınızdayız. Sizlere Kaliforniya'dan Alok'la ağırlıyor olacağız. Alok çok değerli birisi, özellikle data teknolojileri konusunda inanılmaz bir geçmişe sahip. Geçmişte Golden Gate, Oracle gibi çok değerli kurumlarda hem ürün hem de teknoloji geliştirme safhasında liderlik görevini üstlenmiş birisi. Bugün de bizlere aslında datanın geleceği konusunda çok güzel bilgilerle donatıyor olacak. Ben sözü kendisine veriyor olacağım. Umarım keyifli ve güzel bir webinar olacak. Sorularınız olursa Q&A tarafından yazabilirsiniz. Artık başlayalım. Alok, stage is yours. So please.
Okay. All right. Thank you so much, Ibrahim. And good morning, everyone. It's a pleasure to be on the call today. And thank you for logging in into this webinar. Today's topic that I want to share a few thoughts about is called Remote Everything and Digital Transformation, with a theme of simplifying data modernization with a streaming data architecture. So as Ibrahim said, my name is Alok. It's going to take me about an hour to cover the content. And I'm going to try and keep the flow moving along rather rapidly. In terms of the actual content, the first part of the webinar is going to focus a little bit more on the transformation, modernization, and the role of streaming and streaming architecture. And the latter part, I'm going to get into Striim as a platform itself, as well as some of the technical details. And I'm also going to show you some product demonstrations of real-world applications that you can write to enable modernization and transformation. So that's sort of like the broader agenda today. I am hoping that towards the end, we will get into a Q&A session. So please feel free to type in your questions as they come along. If I get an opportunity to, I'll answer it in line. Otherwise, I'll be sure to try and reserve some time towards the end. If for time reasons we don't get to all the questions, we will get back to you over email. So please don't shy away from sending your questions either in English or in Turkish. If you send it live right now, then I may need some help with translation. But otherwise, we should be good to go. So with that, let's go ahead and start the topic itself. Just by way of introduction, I run engineering and products at Striim. So I do have knowledge about what's on our roadmap and upcoming. I'm going to try and reserve my comments to our GA technology today, but just in case I refer to the future, there's a safe harbor statement here. So please don't read into anything that I say today as far as any guarantee that Striim takes for it. But I will be very careful and try to reserve my comments on what's GA today. So with that, we have a broad topic today, and I want to just quickly talk about a few ideas and then converge them together. So the first one, if I just rewind us back to February of 2020, there was a very interesting finding from ACM, which was known as the shuttering of the corporate data center. And in a blog post, Gartner had forecast at that time that 80% of enterprises will have shut down their traditional data centers by 2025. Oracle itself predicted that 80% of enterprise workloads will move to the cloud by 2025. And this was a pretty significant finding as far as where we were going in the technology sector. In May 2020, a new reality has hit us, and all of us are privy to it. I don't want to dwell too much into it, but it has changed things rather significantly and very, very rapidly. And I want to give you a few data points just between February and May. The current pandemic that we find ourselves in has seen another shift. Particularly, we're seeing that a lot of the CIOs are prioritizing what they deem as more mission critical applications, mission critical services, on top of, as compared to just a general transformation category. Okay. And so within the broader area of business transformation, there is this particular emphasis on digital transformation. Okay, so that's one specific thing I wanted to share. And secondly, this whole concept of remote everything. In almost our daily lives, it is hard to shy away from noticing that everybody is working remotely, more or less, other than a few essential healthcare workers and a few essential businesses. And particularly how businesses are reacting to this, how are they reshaping some of their current approaches to businesses, vis-a-vis reacting to working remotely, collaborating remotely, offering services remotely, offering customer experience remotely. It's really radically imposing a lot of newer requirements on the business. And we definitely, again, think that there is some amount of investment in the area that is related to online services and online distribution of the various assets that people have, including any products or including how we collaborate and so forth. Okay, so what if this is a very broad area, so a few points that I wanted to share that we are seeing, particularly in the technology industry and with the businesses that are involved here, is number one, a lot of the decision making is becoming, immediate. Many of the 5 to 7 year roadmaps that many businesses had, we feel like that time is being compressed and crunched to within a 5 to 7 months, which otherwise was 5 to 7 years. And a lot of businesses are being fundamentally forced to reshape their thinking. And what that really means is that, number one, they need to be very, very modern when it comes to things like mobile applications, or cloud analytics, or cloud adoption, or how they're collaborating, or how they're offering their own services. And that is resulting in a lot of the operations becoming online and becoming real time. And this emphasis then on what originally used to be, hey, I want to get and do analytics, is becoming more and more, I want to do real-time analytics. The fact that I could do end-of-day processing is shifting more and more to, I want to do immediate processing, because the services have to be available, they have to be up 24/7, and they have to be shared in a very new manner. And it's noteworthy, just last week, I happened to catch Microsoft CEO Satya share that Microsoft itself has shared that they've seen 2 years of digital transformation in just 2 months. Okay, and this kind of is intended to show just the current mindset of what's happening, to businesses, and how does that relate to, the broader area of business transformation, and then the more focused area of digital transformation. So what do we mean by that? Okay, so digital transformation is a cornerstone of a service that's delivered on a now basis. And what do I mean by that? What that means is that in every part of the business, you really need to modernize it by having a digital approach, not just to one specific part of the business and then leaving alone another part of the business, because that fundamentally doesn't quite achieve transformation in the entire end-to-end business workflow. So you really want to incorporate digital technology into all areas of your business, in order to just fundamentally shift the experience that you're giving to your end customer. Okay, that's what I mean by digital transformation. So if you step into it, what we mean by that is newer ways of engaging customers through things like having a bot experience, having a context-based experience, incorporating machine learning, incorporating speech recognition and natural language processing, things like that. Okay. You want to deliver more operational excellence and efficiencies, especially in this environment. We are definitely seeing that a lot of businesses are looking at initiatives where they're optimizing their costs, and they're trying to figure out what can they do to different parts of their business to optimize that. Trying to make sure that in light of the new way in which services are being delivered, there's enough, enough of an emphasis on addressing and managing risk and security and compliance. And many of these things are just new. We're in the last couple of months, as we have seen. And lastly, this is resulting in businesses fundamentally trying to deliver newer services. And this goes across the industries. It's not just one specific industry. Okay. So if you take a look at, financial services and how they're working today, earlier, the regulations and rules required them to conduct their business in a certain manner. But now, due to the sheer inability of people having to, having limitations as far as traveling to a certain location or trying to get to a certain document, that has changed the nature of how information needs to be accessed in that industry, how insights need to be delivered, how aggregation needs to be delivered. Same for healthcare. Particularly healthcare is extremely important right now. As all of us are aware, information and data that is being generated in real time all across the globe, how does that make its way so that more and more independent businesses, more and more research labs, more and more academic institutions take advantage of these data sets and offer the information in a real-time manner, in a high-quality manner, in a condensed manner, and you're seeing the results of this right in front of our eyes almost every single minute by minute on any online forum or any newspaper and so forth. So it's not unique and specific to just a single industry. We are seeing this across the industry. Okay, so I just want to touch on a few data trends. Then we're seeing these over the last 20 years or so, from 2000 to 2020. And if anything, in the last few months, like I said, the impact of these trends is pretty much forcing all businesses to react. So the first one is data itself. Earlier, there used to be a lot of human input as far as data is concerned. Pretty soon that machines started generating data, and now devices are generating data. And I don't need to tell you, many of us are looking at the sheer magnitude of the large volumes of data that we need to store and manage and analyze and ultimately deliver. So clearly there's a shift in terms of how data is being generated. The location part is also interesting. As more and more applications are making their way to be cloud native, that's also changing where data sits, where does it originate, how does it move, and there clearly is a shift there with data that's being generated on premise to data that's being generated on the cloud, and increasingly across the hybrid environment. As far as data processing is concerned, we are seeing trends as people want to process more and more data in memory, obviously for latency reasons, for real-time purposes, and trying to take advantage, not only because of the fact that you want to deliver the data in real time, but also from a compute point of view, as newer hardware-based acceleration techniques and things like GPUs and FPGAs and so forth are coming into play for either high-speed analytics or for machine learning. We are clearly seeing a trend in terms of how the data processing requirements are changing. In terms of timeliness, I mentioned this from high latency, what used to be okay maybe last year is no longer acceptable today. All of us are continuously trying to initiate searches or look for queries or look for answers or look for directions or looking to deliver things online or place our orders or interact with a customer service agent. And so clearly there's a rapid shift towards low latency services, low latency data. And then in terms of analytics, what does that mean? That means that earlier, you could get away by having analytics more at a larger granularity, where maybe every week you get a report, or every month you get a report, or you run some sort of a analytics flow. And now that you need to be more and more proactive, you need to start looking at, can I try and predict the behavior as opposed to what the behavior is historically? And that's kind of a trend that we're also seeing. And lastly, in terms of the data movement, I think this is going to be one of the main things I touch on today. Moving away from batch ETL to more real-time data movement or streaming integration, and trying to incorporate streaming architectures for real-time needs. That is another interesting trend that has occurred. Okay, so these are kind of the macro level trends. And if you take a look at the technology landscape today, it is shifting. It used to be that you were on the left side of this picture, where up and down the stack, you had your popular databases and messaging frameworks and your popular applications. And more now what we are seeing is, number one, best of breed applications are being offered not necessarily on premise, but in the cloud. If there's a best of breed security application that's being offered on one of the public clouds, you just can't live without that. And so if a part of your business starts adopting that, then that clearly has implications on how data moves, how it gets aggregated and analyzed, along with all of the other areas of your business. And so we clearly are seeing a massive shift in the technology landscape, where newer frameworks, newer applications, newer endpoints, newer applications, newer databases, newer analytic systems, newer data warehouses, newer data lakes, these are beginning to come into play, and they are being offered in the public clouds. And increasingly you're trying to pick the best of breed solution for your business, and then trying to interoperate that with your existing investment in your technology solutions. So we are seeing this emerge in the technology landscape. And so how do you manage this is sort of a key piece of transformation. Okay, so I guess there are two main things that I wanted to cover today, as far as what is really needed for digital transformation. What are the two very strong things that you need to address? So the first is, as you take a look at the way data is being generated, and more data is coming through from either your existing transactional systems or from your file systems, from your devices, or over the web. There's a need to process this data and every aspect of it, the ingestion piece of it and the processing piece of it, possibly the augmentation, enriching part of it, and then the storage part of it, analytics part of it, and all those things. So this is really requiring what generally we refer to as the ability to deal with streaming data. And so streaming integration across these multiple endpoints, these multiple systems, is emerging as a key infrastructure requirement for digital transformation. Okay, so that's point number one. And the second piece is cloud adoption and innovation. So if you take a look at, let's say if different parts of your business today are running on premise, the first question to take advantage of digital transformation is, hey, how can I actually get economies of scale? How do I have elasticity in my business? How do I avoid lock-in into a specific vendor and so forth? So clearly that is leading to investigation of your newer areas of either redeploying, re-architecting, rehosting your existing application services and platforms on the cloud. The next step is, how do you go multi-cloud? Because again, you also don't want to just necessarily, you want to have the freedom, you want to have the choice and not be necessarily tied into a single cloud, but especially because you may have one cloud service provider offer something that is a best of breed solution, and another cloud provider providing a best of breed analytic solution, and you want to again make sure that you're able to incorporate both of these within your technical ecosystem. So how do you do that? And that's sort of is the multi-cloud strategy. How do you add another cloud platform? And lastly, how do you switch easily? And this is also leading to sort of a common set of infrastructure services, so that once you actually have a deployment model on a single cloud, can you easily move to another cloud, and can you just make this shift as easy as possible? And so there's a bunch of technology that's coming up in that area. So these two pieces. So one is the streaming integration, which allows for sort of dealing with the sheer amount of data that's coming in continuously at you. And the second one is taking advantage of all of the services that are available in the cloud, so that you can really scale your business as you go from maybe an SMB to all the way as you grow your business, and take advantage of the cloud. These are the two very, very interesting requirements that come up as you're trying to introduce digital transformation into every part of your business. Okay. So one thing worth noting is, why is traditional data integration not sufficient, and why are those data pipelines not adequate to handle this? And there's a number of reasons. Each one of this is a fairly detailed point. It's obvious that many of these things were built several 30, 40 years ago, notably ETL. It's worth noting that even today, close to 80% of ETL is still homegrown, which means that people and businesses are building their own scriptware and so forth. So a lot of that is batch oriented and not real time, and it's hard to do that in real time. Number two, it's not built for the cloud. If you take, to give you a very practical example, if you traditionally were able to connect to a system, it's not so easy to move that same technology to the cloud, because of the fact that networking comes in, firewalls and security, and you have other implications like that. But fundamentally, when you connect to the cloud, you should always be aware that there could be failure points and new failure points that can be introduced. And so a lot of these systems that were built traditionally are not ready for the cloud. They have scalability limits. So as you can actually horizontally, let's say, deploy your compute servers or storage, if you're invested, for example, in a system like Kafka, and you can keep adding, more and more nodes to the Kafka cluster, and adding, scaling with your topics and partitions, can you also scale your integration solution along with that? Many of these traditional architectures are very job oriented. They run and then they shut down, and that's a very different paradigm than, and it runs kind of contrary to the real-time paradigm, where each event as it's being generated, you may not necessarily want to push that into a report, but the fact that you want to collect it and ingest it and even make it available into a storage system just to deal with the sheer volume requires you to immediately deal with it, as opposed to saying, end of night, we're going to run an ETL job for this thing. Then there are newer things. As you have this landscape, you have data residing in different in different systems. Are they consistent? Can you compare them? Can you make sure that in fact it's the same data? And how do you validate that? Also, as you move the data, are you able to augment it? Are you able to encrypt it? Are you able to mask it for PII and so forth? So those are interesting new challenges that are coming up. And lastly, in the pipeline itself, do you have a smart pipeline, or is it just a pipeline? And this is a very significant point as far as anytime we have seen in the past when you were able to connect two endpoints, either through something as simple as a pipe, or as simple as an actual road or a freeway. As it becomes more and more sophisticated, newer businesses spring along on the pipe itself or on the freeway itself, and those offer their own services. And so data pipelines also need to do that, where they need to give you feedback from the pipe itself, saying that, hey, I think something is wrong, or I'm seeing an unusual pattern, or I'm seeing an anomaly. And this is sort of how you modernize your data pipelines so that insights are being delivered to you as opposed to you constantly polling for insights. Okay, so these are some of the reasons, and I'm happy to get into this. It's a fairly detailed area. So with that, I think I've covered about 25 minutes, just kind of setting up the stage towards the introduction of Striim itself as a platform, and where it can help digital transformation, and how does it help to modernize the business. So this is going to be now the second part of the presentation, and I'm going to get into more technical depth. Please feel free to ask questions, and I'm more than happy to get into as much depth as possible. Like I said, this is going to become crystal clear once I actually start showing you some of the applications also. So as far as Striim is concerned, it's a next generation platform, and there are three areas. There's three solution areas. The first one is the area of cloud adoption. The next one is the hybrid cloud data integration, and the third one is in-memory stream processing. The way to understand this slide is, on the left-hand side are your on-premise systems or your cloud systems, and on the right-hand side are your cloud targets. They don't necessarily have to be cloud targets. This can also be an on-prem target, but increasingly, like I mentioned, we're seeing more and more businesses trying to take advantage of cloud services. So as you look at the left and the right side of the picture, there are a number of different solutions you're trying to introduce. Cloud adoption has very simple flavors. You could have an existing database on-premise, and now you simply want to move to a managed database in the cloud, and you want to take that journey and you want to just migrate your entire database. That could be a use case, for example. You might want to do data replication, where you're running, certain applications on-premise backed by a database. A newer application needs to be deployed in the cloud because you don't want to scale and spend additional investment in the on-premise system, and you want to replicate a portion of the data so the newer application can be deployed in the cloud. That's the data replication part of it. And the third is data distribution. We are seeing a lot of innovation in this area by businesses, where typically, if you take a look at data that's coming in either through a transactional system or through just an event system, you're first trying to take that data and push that into a streaming architecture, for example, Kafka. And then you're trying to, you have an interesting set of problems there. You're trying to ingest the data from Kafka itself. You're trying to process that data, possibly query that data, massage it, and then take the journey forward into an analytic system. You may want to push it into possibly a NoSQL type of system, or you may want to push it into just a graph database, or you may want to push it into an analytic system like Databricks. So these are the kinds of things that we are seeing there in the data distribution category. So again, the key point: you have existing systems, you have newer systems that may either live on-premise or they may live in the cloud, and you're either trying to migrate, or you're trying to replicate portions of data, or you're trying to completely, or you're trying to distribute the data across these systems. The second category is now generalizing the previous one by saying, now I want to move data not only from on-premise to the cloud, but also from the cloud to another cloud or from the cloud back to on-premise, because my reports need to account for all of the applications. The service that I'm trying to deliver, which is a new service, requires data from multiple endpoints. So again, there are an interesting set of solutions you're trying to deploy there, which have to do with either doing a data integration across these endpoints, or trying to deploy some big data applications or some cloud analytics applications. So that's the second tier here. And the third one is what I call, I talked about the smart pipe and the innovative applications. So these are, think of them as either microservices that you're trying to deliver or very thin applications that you're trying to deliver on top of data. And typically operational monitoring type of use cases, even use cases that have to do with push-based alerting when an interesting event happens, or trying to take data as it's coming in and pushing that into a model that you have built, which is one of the machine learning models, to try to either score or predict, and then trying to integrate that into either a risk engine or a recommendation engine or a search engine. Those kinds of use cases come into this area. And finally, digital transformation is all about delivering newer services, newer solutions. So are you able to deliver new applications rapidly, quickly, without having a lot of development time for months and years? So there's this complete shift towards trying to deliver very lightweight, thin applications, which we call streaming applications. So that's this third category. Okay, so this is covering a lot. I'm going to go through this thing more practically as well, but this is just a larger view of the capabilities that the Striim platform itself delivers. Okay, so I want to cover just a couple of use cases before I get into the technology part of it. So as far as Striim is concerned, it's we've successfully proven that across multiple verticals, be it financial services, be it travel and logistics, be it healthcare, be it telco and utilities. A lot of them have similar problems, the ones that I mentioned earlier, as they're trying to change their businesses, as they're trying to take advantage of real-time operations, real-time insights. So we've been pretty successful helping deliver these solutions to these customers. So I just want to step into a couple of them. So the first one is a very large consumer credit reporting agency called Equifax. It's one of the large three here in the US. And they had some challenges as far as trying to approve loans and so forth in real time. It used to take quite some time, and that required them to take data from an existing Oracle database, which had payroll and employment verification, things like that, and trying to take that and combine that with third-party information, and then quickly try to deliver that into a system like Google BigQuery, so that they can immediately not only move the data in real time, but also improve the borrower's experience by making a decision very quickly. So earlier, what used to take them, multiple days for employment verification now can be done in real time, and that significantly improves the lender's experience. And the technical solution, for those of you who are running infrastructure like this, if you have an Oracle database, in their case, they were also running Golden Gate as a replication solution. So we were able to ingest the data from the Golden Gate Trail files directly, combine that with some file data, and then move that to both Google storage and into BigQuery. Now, take a look at, I mentioned earlier some of the challenges that traditional technologies have. So one key challenge here was, how do you actually just grab data in real time from a system like Oracle or Golden Gate without actually impacting the application itself and getting it in real time at a high volume and scale? The second one is, how do you manage security around this data? This is very sensitive data. So if you're moving it to the cloud, being able to make sure that the keys get managed in a secure way, so that not only we can't look into it, Google can't look into it, so that's the kind of the solution that we provided for both the data movement and to keep the data secure and to land it in an analytic system with only the necessary data and not all the data. Okay. Going forward, another example that I want to share with you is a data aggregation company called Yodlee. So they're a pretty a strong company, and they allow you to take a look at your credit card statements, your bank statements, your investment statements, even your travel accounts in a consolidated fashion. And so oftentimes they sit in between your actual app that you're running on your mobile phone and the financial institution that's actually running maybe a core banking application or a credit application, or a travel application. And so they're giving you that consolidated view. And clearly they have massive amounts of data. And what they wanted to do was take a lot of their data that's coming in from their, let's say, ERP systems, and then they have a large Oracle RAC cluster, and they were trying to modernize the solutions that they had by delivering that data in real time to their application development teams, who were building newer solutions in systems like Apache Kudu and in Apache Kafka. And so they use, again, Striim to deliver that data in real time so that they can, have a very real-time, recent analytic report with the latest data available. Okay. One retail example I'll quickly cite, and I think I have a bunch of examples, but I'm going to probably skip a couple of slides in the interest of time and get to the technology. Macy's is a brand name in the US, obviously on retail, and their business objective was to streamline their order management, inventory management, and catalog data to deliver a better customer experience. It's a traditional brick and mortar business. They have lots of departmental stores across the country. And so they really wanted to modernize. And part of their modernization was to take real-time data coming in from a DB2 mainframe and free that up so that they could run reports on it, and they could share it with others all across their enterprise, and their employees could get access to this data. And so they really wanted to adopt the cloud for that purpose. And in their case, we got the data from their mainframe, and literally did some processing on that data. And there's a number of SQL operators that were applied there, and we delivered that data into Google's Spanner system, Spanner database that's running on the Google Cloud, as well as to Google PubSub, which is a messaging system. And ultimately, their employees were able to build visualization applications on top of this data. So fundamentally, the transformation journey was that after about a year and a half of struggling by delivering this data for migration reasons in the cloud, we enabled a mainframe to talk to a newer endpoint like Spanner, so that on Spanner, they were able to then offer real-time visibility into the inventory and in the order data. So that allowed them to basically manage much better their out-of-stock data and also avoid inventory surplus. And one of the technical points that they shared with me was during Black Friday, which is one of the heaviest peak season for them, the end-to-end latency between the two systems was 250 milliseconds. So from their data center, which was running the mainframe to the Spanner system. Okay. Another example is a bank. In this case, this was again a banking application, and I'm just going really fast here because there's some overlap in terms of hopefully by now you're seeing a pattern here. Again, to try and do financial reporting on real-time data. This time the endpoint was Azure Event Hubs, which is another offering from Azure. It's their own event system. It's also compatible now with Kafka. And so they want to land the data there from a legacy HP nonstop tandem system, which was a system of transaction records. So how do you again get that in real time and move that so that you can actually do reporting on a newer system and retire kind of a legacy system? So these are examples that I'm citing of modernization. Okay, so let me just skip this one. This is a UPS, but for those of you who are interested, I can share this later. So let me get into the technology part of it. So I mentioned the solutions. This was the broad macro level picture. If I just break this down, by now the picture should be clear that if you have a lot of on-premise systems, you should be able to move that data without disrupting your existing system, which is running on-premise, without taking downtime, without taking an outage, allowing that data to move to a cloud database or to a cloud analytic system or into cloud storage on a continuous basis. And again, the idea is that ultimately you might want to migrate to a cloud database, or you're just simply replicating that. As an example, you have a SQL Server database on-premise, and you want to move that into maybe an AWS Redshift system or into Kinesis and things like that. Okay, so that's just an example. Similarly, on the hybrid cloud data integration, you have data moving back and forth, either from one on-prem system to another, or from one cloud to another, or from cloud back to on-prem. Okay, again, this is the broad theme here is that your best of breed applications can get deployed anywhere in the cloud. Your databases and your existing messaging systems that are running on-prem, how do they talk to each other, and how do they talk to each other without disrupting the business, so that you can deliver the solutions in a very, very rapid manner without having 6 months or 12 months worth of application redesign time. And then the in-memory stream processing. These are really your next generation data-driven applications. To give you a simple example, imagine that you have a core banking application, or if you have a supply, or if you even have a CRM application. Can you just count up the number of transactions within a time period, like every minute? And then if it's exceeding a certain threshold, you want to notify somebody, you want to alert somebody, and you want to do this on the data delivery pipe itself, not after landing the data into a target endpoint, right? And so this is what I mean by having a smart pipe itself, where the pipe itself can serve effectively as a query processing engine to deliver insights based on the data that it's seeing. And I'm going to show you an example of this thing. So here's how it works. Okay, so the platform itself is a distributed Java-based platform. It runs as a cluster, and you can have multiple nodes or a single node running depending on the workloads. The different pieces in the platform, on the left side are a number of out-of-the-box connectors that we've already built for you, so that it's very easy for you to just literally connect to a data source and start continuously collecting the data without writing a lot of code. So this is data that can come in from an Oracle system, MySQL, Postgres, SQL Server, HP nonstop, mainframes, on the database side. And when I mean the database side, this is not your traditional classic, I'm going over JDBC or through a native C interface against the tables. In many cases, to make this real time, we have technology that allows us to go at the transaction log level, which is known as CDC, or change data capture. And we're able to get in real time the inserts, updates, and deletes, those kinds of operations, along with the metadata. You can actually get things like the transaction ID, the table name, the column names, the user that's making the change, the session that's making the change, the server character set, all that kind of stuff can come in the record itself, right? So this is the left side of the picture. And this is broad enough where the data capture can happen from a database, as well as from a system like Kafka, as well as from a file, which is either in JSON format or Avro format or DSV format. So we can collect that data, and there's a number of parsers. So you get to pick a connector and a parser, and that combination allows us to interpret that data in the platform. So now I'm going to move the logic into the platform, right? So now I'm in the middle piece of this slide. This is where you actually build a data pipeline, and the data pipeline, allows you to do things to the data that you've received so far. So you're able to filter on that data. So let's say I start off with a very wide record, which has 108 columns. You're able to sub-select and say, I'm only interested in 64 of these columns. Not only that, you're able to say, hey, there's some sensitive information in column number 18. I want to just completely make it opaque. I want to just completely scramble it so that nobody downstream has access to that. So you're able to actually apply a transformation like that in line. So the filtering transformation, you can aggregate it. If you wanted to just partition it. A very common problem in that I see a lot of data architects and application developers struggle with is, I have some sort of a system of records and I want to partition by one entity, let's say a user. Common example, let's say I have a web log and I want to do sessionization by a specific IP or by a user ID or by a region. So you can actually do that aggregation directly in the centerpiece here, right? That's the capability of the platform. This is what we mean by the smartness in the pipe. And then you can also enrich it. You can try and augment the record with newer things by literally adding compute to it. So I could take a concatenation of multiple fields within that and write that into a new field, which is part of that record. Or more interestingly, I could join this with another record and then create a result record. Okay, this is what I meant by the data trend that allows you to go from a purely batch-based processing architecture to a real-time processing architecture. Okay, from primarily on-disk stuff to in-memory stuff. Many of you are probably looking at leveraging Kafka and KSQL and frameworks like that to do this kind of processing. And I do want to say that at least in our experience, when our customers have worked with the platform, Kafka is already under the covers being used for you. You're really writing things at a declarative level. So it makes the delivery and the construction of the application dirt easy, right? It literally saves you the time where you can write that application by using fundamental building blocks as opposed to writing boilerplate code from scratch, which often you have to think about the ingestion and the security and the manageability and the scalability and the event processing guarantees. All that stuff is taken care of because it's a platform at the end of the day. That's the innovation here. And finally, on the right side are the endpoint target adapters that we can write into. So earlier, you saw some of the customer examples where we were moving data from, in Macy's case, from a mainframe onto Google Spanner. So in this case, the mainframe would be on the left side, Spanner would be on the right side, and any massaging of the data that they're doing is in this in-memory data pipeline. Okay, what you are seeing on the top and the bottom, I'm going to show you that in just a second. So here's how it logically works. You can connect to a source. You can do ongoing data collection and from databases, particularly using CDC. And in a solution like, if you just simply want to deliver that to an endpoint, either on-premise, because you're running Kafka on-premise, and that's a perfectly legitimate way to distribute the data downstream, or even if it's in the cloud, you can just deliver it. So this is sort of how you may want to start off a data pipeline. But very quickly, we see that as soon as you adopt this, once I've captured the data from one of the sources, it's really easy to now fan it out to multiple endpoints. And this is a classic, you must have heard of, democratizing the data and freeing up the data. I mean, ultimately, if I am a developer or I'm a data scientist, I don't want to concern myself with understanding the entire part of the stack if all I'm trying to do is write an analytic query or a report. So how do you do that easily is really what this is. So now comes in the middle piece. So there is windowing capability. So if you wanted to aggregate the data in a data window of 5 minutes or 10 minutes, or by every 100 events, you can build a data window. And then you can do some of the things that I mentioned earlier, like filtering and transformation, enrichment, etc. Okay. You could also join the data with an external cache by either preloading that data into the Striim platform in memory. We do have a in-memory cache, or you can do an external lookup based join to bring data from an external platform. So this allows you to augment the data as it's flowing through. The platform is also extensible, so you're not limited to what we ship with. You can also extend it by writing your own Java code, and you can link in with that Java code within the Striim cluster itself. And that's how, you know, many of the companies, when they want to incorporate their own user-defined functions, or they want to incorporate, let's say, a machine learning model that they've already built into the pipeline, they can deploy it in the pipeline. Okay, and then there's a visualization component to this thing, where if you wanted to alert or visualize the data, you're able to do that within the platform. So I want to just, I've said a lot, so I just want to like give you a very simple picture in a condensed manner. This is about ingesting data from a lot of different sources, including databases, including using CDC, including things from messaging systems like Kafka, etc., including data coming in from the web over HTTP, for example. And once we get the data, you're able to either just deliver it because you're trying to do cloud adoption, or you're trying to do data distribution and so forth. Or the third category that I talked about earlier, which is the in-memory stream processing, trying to deliver modern applications. That's the middle piece here. That's optional. You can do it. You don't have to do it, but the platform has the capability. That's the main point here. Okay, so with that, I think what I'm going to do is I'm going to just show you a demo in the interest of time. I have a couple of slides that just talk about some pieces that come in the platform, but I'm going to show you a demo. Okay. So the first thing that I want to show you is just a very simple demo that allows me to show you an initial load that's being done. Imagine that you have a Postgres database, and you're trying to move data into another Postgres system, which is either in the cloud or on-premise, doesn't really matter. So what does that look like? What does the experience look like? So let me just play this for you. I also have a live cluster. If we have time, I can step you through that. So what you're seeing here are different pipelines. I'm going to step into one of these application, we call these pipeline groups or application groups. And you're seeing a number of different tiles here, and each one of this is a pipeline. So I'm going to focus on the Postgres to Postgres initial load pipeline, and we're going to move about 150,000 records. It should just take a second or so. So let me just connect to the Postgres database first and show you the table that I'm going to move. So this is the customer table. Let's go ahead and query for the row count there. And you can see that it has 150,000 records. I'm going to move this into the customer target table, which is the target side table. And the row count here is 0. So this is the one-time load, which will be followed next by the ongoing changes. Okay, so that's the point. So you can see that currently there's no records in the target table. Okay, so let's come in here and go ahead and start our application. It's going to be important for you to know that as the data is flowing through, you can actually visualize it. You can see the data along with the metadata. So you go to the flow designer in the platform. On the right side, you can see the configuration of the source database and how we are reading the data and the fields that we get. So you can see the data and the metadata. You can also augment it by your own user data, for example. So let's go ahead and start the application. That starts the pipeline. This now starts flowing the data into the actual Striim platform. If you click preview, I just click preview, you can visualize the data underneath. So you can see that I can see the table name, which is the customer table. In this case, I'm just doing an initial load, so it's a select operation. It's not a DML operation. On the left side, you can see the actual data contents, which are all the columns in that table. Okay, and you're able to like pause this and examine the data if you want to. Let me just log back very quickly into the target table and show you that, in fact, the row count now is 150,000 records. Okay. So that's kind of how you do like an initial load. So all you have to do is build that pipeline. basically connecting to the two systems and starting the pipeline. Okay, and you can do that for multiple tables, multiple schemas, the entire database, and so forth. So that was my first pipeline. Now I'm going to show you the second pipeline, and the second pipeline is showing the actual change data capture. Okay, so let's go ahead and run this one now. Okay, so now I'm going to focus on the Postgres to Postgres change data capture. Let's step into the flow designer again. You're seeing that there's a source again. In this case, now we are not going to select the data from the actual table, but from the redo log. So in Postgres, we basically have a replication slot, and we get the data from the replication slot. If it was Oracle, you would get from the redo log. If it's SQL Server, from the transaction log, and so forth. MySQL would be the bin log. You can see now the configuration is very different here because we're trying to read from the log. Once you start the application, then it's watching now for ongoing changes. So let's go ahead and quickly insert 250 records into the source table. So I'm going to execute this. This is a very interesting thing where from within the Striim application, I can execute a workload that's external. That's done through a component called the open processor, which you can program yourself. There's an alert that just popped up which says, yes, we were able to execute 250 inserts. And now I'm going to log back into the Postgres database and show you now that in the customer target table, you should have an additional 250 records. So let's go ahead and do a count star. And now you can see there's 150250 records there, right? So it's as simple as that. So the idea here is that, I just demonstrated the CDC capability to you. Okay, so we are at 101. I do have one more last application. I see still a number of people logged in. Maybe since we started 4 minutes late, maybe I can just show you one last demo here as well. It shouldn't take more than a minute. And this is the demo where we write this to Kafka. So let's go ahead and do the same database now is going to start writing data to Kafka. Okay, so in this case, I'm going to focus on the Postgres to Kafka application. Again, step into its flow, into the flow manager. Look at the configuration. It's the same way in which we are getting the CDC data from the Postgres log itself. And in this case, now the endpoint you can see is I'm writing to a specific topic, and you can see the broker address and the topic. Again, you don't have to write any Java code or anything like that. You're just picking the endpoint here, and you start this application. And I'm going to again show you the preview of the data, and you can actually see the data in this case in JSON format being written to Kafka. Okay, so I'm going to show you another application. Sorry, let's go ahead and run the 250 inserts so that there's some workload against that application. Now it's running. And there's there you go. So now I'm seeing the metadata. In this case, you're seeing the same table name. You're also seeing interesting things like when the transaction was committed and so forth, based on the logical sequence number, the LSN from the redo log. On the left side, you can actually see the data. Okay, so I know we're slightly over time, so I'm going to just pause this here and just quickly go back to my presentation as to how you guys can get your hands on this. Okay, so let me just very quickly cover one slide. You can deploy this on the cloud or on premise. It can run as a container, it can run in a VM, or it can run bare metal. And it is available for downloading from our website. You can also get an image, a Docker image from Docker Hub. And there's also a trial period, and you can try it in any of the 3 public clouds as well. So just to summarize, today I wanted to share some thoughts around digital transformation and on the role of streaming integration towards modernizing businesses. Clearly, just to summarize, we are seeing a massive shift towards investment in hybrid cloud, a shift towards data-driven services to both optimize workflows as well as cost. a shift towards real-time operations to deliver next-generation customer experience, and finally, a shift towards next-generation analytics for getting real-time insights. And Striim can help you with two very, very fundamental tenets of your modernization initiatives. The first one is cloud adoption. I talked about that quite a bit today. And the second is the real-time data solutions. So whether that has to do with real-time data collection, real-time data ingestion, real-time data delivery, real-time solutions that you can build, real-time visualization on top of that data. So those are some of the things that I covered today. So I'm going to stop there. Thank you so much for your time today. There's a few questions here. So for those of you who are here, I'm going to take a couple of questions right now. And thank you very much. Before I forget to thank everyone for your time today. I realize that these are trying times, and I really appreciate your participating. And I hope you learned something. My email is alok@striim.com. In case I didn't cover something, in case I confused you about something or something is unclear, please feel free to email me. All right, so the first question is, hi Alok, I didn't see Elasticsearch among big data adapters. Can Striim write to Elasticsearch? So yes, Striim can write to Elasticsearch. So you should be able to do that. The one catch-all here today I didn't cover was we do have the ability to program your own open processor. So that's something that is code that you can write on your own. So let's take a brand new system that, let's say, Striim doesn't support today. Let's say I'm just going to call it Gremlin. Okay. So to the degree that Gremlin has their own native APIs and there's a Java client available for that, we can take data from our system, push that into this open processor, and either our field or you guys can just code it directly yourself. And this gives you the flexibility in the platform to go ahead and deliver it to any endpoint that you want. And you naturally get advantage of a lot of the pipeline from a configuration, manageability, security, event processing guarantees, and other things that I talked about. Okay, so that's the answer to that. Hi Alok, how do you see, second question, hi Alok, how do you see the future of cloud for banks and telco in Turkey? I'm not an expert in the Turkish market necessarily. However, I do have a lot of people I talk to, both customers as well as industry experts that deal with many of the businesses in Turkey. If I go back maybe a year or 2 years, I think that there was some reluctance in terms of trying to shift very rapidly towards the cloud. I do think that it's changing, and more businesses are asking about it. The one trend that we for sure are seeing is the real-time trend, and that has to do with the fact that once data is being collected in legacy or traditional systems, how can you free that up so that newer infrastructures can take advantage of it? So when I say newer infrastructures, it could be a system like Kafka, or you're maybe using a Spark-like platform and so forth. So how do you take data from maybe your Oracle system or your DB2 system or your SQL Server system and deliver that to a platform like Spark so you can run your Spark jobs on top of that or ML on top of that? That's something that we are seeing. In fact, when I was in Turkey last, there were multiple customers that brought that up, and there's those kinds of solutions are being discussed with them. So that definitely is something that we are seeing. Okay. I think what I'll do is any other questions we'll probably take over email in the interest of time. So hopefully you enjoyed it. Ibrahim, thank you very much for having me today, and I'll hand it back to you.
It's our pleasure to host you, Alok. Yeah, it's really, you gave lots of information, lots of great information to our webinar participants. Thanks for your participation and giving this great webinar. Thank you.
Thank you so much. Bye-bye.
Bye-bye.